crooked. Crooked. But as long as it's getting equal water on them,
It's not.
it's not.
A lot of
It's
it's
going past this one, I know. There was wind here before, and that has effect on it. But it's going over the top of that one. And it's definitely there.
Lots of
So the area of these pans are set up so that 1 inch of rain equals about a gallon of water. So if we put on an inch of rain, there'll be a gallon in this one, a gallon in that one. And we'll be able to determine, how much stayed in the pan, in the soils, how much went through, and how much ran off. Hopefully it's capturing it all. To look at too is over here. This is soil that those raindrops, they're hitting the soil so hard, it's exploding them up, this high onto the backboard.
There's the move.
I mean, this one's pretty simple to see what's going on. It had the same effect that what we saw with the aggregates just collapsing when the water goes on. It seals off the soil so that water can't penetrate, so that it has no place to go but off the top. But with it, it takes a lot of fine soil. This was 1 inch of rain, and you can imagine over decades, hundreds of years, thousands of years, what we're losing in our soil. Now this one is a pretty healthy soil of it, but we still had runoff on it. The difference though, this one, every place I take it, it surprises people that this soil with just a little bit of coverage makes a huge difference. And what it's doing is the straw is slowing down the water so that it can find a way slowly into the soil. It doesn't explode the soil. It starts, once those raindrops hit, it starts to move the soil, and then they're easy to wash away. But this slows down this rainfall so that the water finds its way down through different cracks into the soil.
What's the difference between the first two?
These two?
Yes.
Same soil. This one was on the edge of the field growing grass, so they didn't farm it. This one was tilled for 5 years in a row. So the tillage is where you get the breakdown of the organic matter.
What about the cow's feet?
Cows?
The feet, they're...
Oh, okay. I mean, these are corn silage fields. So, I mean, if there was pasturing going on, I mean, are you asking if they also cause that
Yeah,
kind
well,
of...
I've heard they compact and I've heard they aerate.
Absolutely. Yeah, I think that's, as I travel around New York, I think that is the one issue that grazers have to figure out how to deal with is compaction. That's our one limiting factor. Because we're already doing a good job. We have an actively growing crop year-round. It's collecting sun. It's all wonderful, except we need to graze sometimes when it's raining out. And those cow hooves, you figure out how 1,000 pounds onto 4 hooves, about 5-inch square. That's a lot of weight divided onto those square inches. And so it's like, in the way to deal with that is make sure there's a lot of organic matter in the soil, either by leaving residual or doing bale grazing or compost adding. Anything to help with the organic matter in the soil makes it more resilient. But if you're grazing hard, taking it right down each time, And then continuous grazing is the worst, where you see the bluegrass out in the pastures, and it's nothing but bluegrass. Those cows have to walk over that just to get a mouthful. They have to take 5 steps. So these are all things that grazers can do to improve their soils. And how did this one work out this time?
Well, it's interesting in that the one with the weeds in it has clearer water.
It is, yeah.
Is that the same soil type?
No, they're totally different. And these aren't a good comparison. Usually I like to have the same thing when you're doing a soil test. I think, and I've seen this color before, and I have a feeling it's a mineral thing, more than a soil. But you're right, that there was better, or no, they were about equal, aren't they? Equal infiltration that went through them. Neither of them had runoff. But I think the one thing we noticed yesterday doing this demonstration was this one that appears to do pretty well because it has less runoff the back. Look at the back jars compared to this one versus the healthier soil. There's a tremendous amount. These are, this one's a little bit more, but this has a lot more that went through, where this one had only a small amount went through. Anybody want to take a shot at why that is? The amount that went through is so much different.
It still had more runoff, that's why, one reason.
That's, we can, let's, what can we do to take that argument away? Maybe it's not as big as I think it is. I didn't. Okay, all I need to do is, so we'll add these two together. So there's quite a bit of difference in the water that went through there.
That one in the middle there held on to more water. It's in the soil. It's not through the soil.
Exactly. And you want to go deeper into that? Why it did that? Organic matter, and it's the those pore sizes we were talking about. It has more water holding capacity, this soil. Because more of that water stayed into this soil, because they've been rained on exactly the same amount over the last, I've been using these trays for a while, but and the same thing happens each time, that this one just can hold on it, and when we get through a drought like we just went through, this is the soil you want, because this can hold that reservoir of water for the plants. The straw did a nice job preventing runoff, but it didn't help with those aggregate pore sizes.
The soil under the straw is like the one on the far left.
Yeah, they're the same.
Your left, our right.
Yeah.
Very good.
Okay. Hope it's close to lunch, and we can end on a positive note.
I hope it's close to lunch too, because I'm hungry.